Hello, hello. So thank you for coming out this afternoon. Before we get started, I'd just like to remind you to turn off your cell phones. I know it's not a movie theater, but still it could interrupt the presentation and disturb your neighbors and all that. So please do that. Also, there'll be hopefully time at the end for questions. And there'll be some QR codes at the end to take a survey. So when that's through, please take your time to do that. Give us some feedback on this presentation, what we can do to improve, and that type of thing. So let's go ahead and get started. So today we're here to talk to you about emerging realities and multiplying wonder, and that's kind of an interesting title. But dropping into a VR game can be really exciting. But today we've got a couple of developers here that we're going to have you talk to that have taken a much more difficult challenge, and that is developing in mixed reality. Because when you develop in mixed reality, it's not only the gameplay, the mechanisms, the plot that you have to worry about, but you also have to worry about the environment that you're in and how you can make gameplay interact with that. But if you get it right, if you overcome these obstacles, the gameplay can be absolutely a magical experience. Now, there's a lot of MR games that are out there now, and there are a lot of them creating magical experiences. So please, download a few. We've got, of course, Spatial Ops from Resolution. You'll hear some more about that in a minute. We've got Starship Home, which you'll hear about, and Niantic as well. But when I was pulling together the presentation for this talk, I had just finished testing an MR game called Guardians of the Realm. And I wanted to kind of explain to you what was happening in that game and why it was such a magical thing. So I work downstairs in my house. I have a living room downstairs, and I have a patio door that faces my backyard and a window that faces my backyard as well. And so I go into this game, and the idea of the game is it's a combat game where these attackers start coming in. And so what's really cool, you look out in your own backyard, and you see these warriors kind of creeping up, coming in to your back patio. So you have a sword, and you're fighting those guys. And then you turn around and see them flying in through the window. And I mean, I tell you, the sense of immersion that you get with that when you're in your own home and you're in your physical surroundings and there's these invaders coming in. Now, these could have been anything. They could have been zombies, aliens, attackers, whatever. But that kind of experience where you can mix that reality that you've got in your house or wherever you're playing with the virtual reality of these things coming in, it just creates really interesting experiences. So we have a packed agenda today. The speakers, myself, of course, and the others here that you're going to hear from are all experts in MR gaming, and they're going to give you some of their insight as to what's going on. Now, we're going to start out, I'm going to introduce mixed reality just to kind of get everybody on the same page, understand what we're talking about when we say mixed reality, and some of the terminology that we use, like scene anchors and pass-through and that type of stuff. And then we'll turn it over to our expert, Doug Northcook here, who is a real expert in MR, and I'll introduce more later about that. But his company created an app called Starship Home, and so he's going to give us some of the lessons that they learned in creating that and kind of talk you through how to create some great MR experiences. We'll then come back to me, and I'll talk about the Passthrough Camera API. Now, the Passthrough Camera API is a new API that's just released into public release last Friday, and it's available now for all of you guys to play around with, and it will allow you to take your MR experiences to the next level. So I'll kind of introduce the concept of it, and then you'll hear from two of our partners. We've had it in partner experimental since, I guess, December, and two of our partners that have played with it and created some neat experiences, and so they're going to show you some of those and some ideas around using the Passthrough Camera API. So, with that, let me talk a little bit about mixed reality. Now, we break mixed reality down into three basic components. We've got pass-through and occlusion, anchors, and scene. When we talk about pass-through and occlusion, what we're talking about there is that there's forward-facing RGB cameras in the headset itself, and they give you this pass-through of what the room is, and it's projected into your skybox. So that's pass-through. In addition to that, we have the depth API, in which it allows you to detect how far things are away. Now, the value of that is you can create something called occlusions, and occlusions are where you take a virtual object, pass it in from a physical object, and you no longer see the physical object, or the vice versa. You pass a virtual object behind a physical object, and you can't see it. So that's what we call occlusions, and that's a very basic component of what creates reality. In addition to that, you have a lot of other things like lighting and shadows, but nonetheless, that's the kind of the ground basis of what you're doing. Anchors. What anchors are, and you hear people talk about spatial anchors and scene anchors and a bunch of stuff, different things like that. But what an anchor is just a point in a 3D coordinate space where you can come back to. So let's say you want to place a poster on a wall. So you'll have an anchor that you put there in that particular three-dimensional space. So when you come back, that poster's still in the same place on the wall, and it anchors to that. Finally, we talk about scene. Now, what scene is an understanding of what your room is about. So we use object detection to tell what's in your room and what's in the scene, and it can identify things like, okay, that's a wall, that's a ceiling. Okay, that's a ceiling. You know, that's a couch. This is a bed. And so you get these kind of objects that come back to you that are in a particular point in space with particular bounding boxes that are semantically labeled, bed, couch, table, whatever. And now in doing that with your gameplay, you can say, hey, I want spiders crawling across the ceiling. So you know where the ceiling is, you put the spiders, they all attach to it. You're all good, right? Or you've got a board that you want to place only on a table. So you put that board on the table. So you can make your gameplay react, understanding the semantic components of whatever your room that you're in. Using those three things together, you can really create some cool MR experiences. And in addition to that, we have something called building blocks. Building blocks are these little components that we just click and automatically add into your scene. So you can click something there and it'll give you a camera rig. You click another one, it'll give you pass-through. So it's really easy to get started experimenting with this stuff. So look up building blocks. But what's most important is the experiences we're trying to create. So what kind of things are we trying to create? We're trying to create really immersive experiences. So as you see this one on the left here, you will see that as the virtual objects go behind the couch, you don't see them. You see them bouncing off. So they'll have collisions with the physical objects using something called the room mesh. And so using these different types of things, it creates a super immersive experiences. But in addition to that, you also have to have some amount of adaptive interactivity. What we mean by that is all the rooms are different. And this is what makes developing an MR particularly challenging, right? Because you come into one room and all you have in there is a bed because it's a bedroom. You go into another room, it's a kitchen. Well, wait, there's no beds in a kitchen. The living room has something else. So your gameplay and adapting to that is really tough. And that's why the scene description that I mentioned earlier with semantic labels can be so handy because you can say, okay, I now have some understanding about the environment I'm in and I can make things react, only put things on walls or do different things like that. So combining all those together, hopefully you'll create a great MR experience and use some of the tips that Doug is about to give us. So let me introduce Doug at this point. Doug is the creative director at Creature. When not gathering up DICE awards, he creates amazing experiences and has several under his belt. So we really listen to this guy. He knows what he's talking about. And Doug?
All right, wow, thank you. So what I will say is that I will only be talking for a few minutes, and if you want like the full Starship Home experience, you should go to our engineering director, Mark Schramm's GDC talk, Thursday, 3:30 p.m. in room 2018 here in the West Hall. Okay, so I'm Doug Northcook, let's ignore that. I'm gonna show you a little bit of our game, Starship Home, right now. And I'm going to turn the volume down a little bit, maybe, if I can. So what you're seeing here, this is all shot through the Quest 3 camera. And in Starship Home, we turn whatever room you play in into a starship. That room then takes off, goes into outer space, and you collect specimens of alien plant life, and then you go inside of their dreams. And really what we tried to do was pull together like the most expert, most senior team that I could find on the planet to try to solve what at the time were some very impossible problems of figuring out how do we make objects feel like they're actually in your room, that they belong on surfaces. And Kirk was talking a little bit about some of the scene data, which has a lot of noise in it, and it's very hard to get these kinds of interactions to work in a way that creates the kind of immersive, very compelling illusion that we're talking about. And so that's the launch trailer for our game. And what I wanted to do is just talk you through a few kind of key ideas and lessons that we learned when building. An early one, and this was kind of a day one prototype for us, was and carried through all of our work, was this idea of surface awareness. Right? And like now there's a lot more data that you can get from the scene, but when we started building, we were originally building on Quest 2 and on Quest Pro, which didn't have depth detection, which didn't have any of the features that are now in Quest 3. But what we did know is we do know that we can get surface data of some kind. And so we worked very, very carefully to try to think about objects and how they would interact with any type of surface, even if we didn't know what that surface was. And so you see a lot of that here in this shot, where we have one of our plant pots that when you have one of the pots in your hand and you let it go, it just hovers with little jets in the air. But if you take it near a surface, you start to see a blob shadow go down onto the surface. It gets darker as you get it closer. Little legs come out from the pot, and then the pot will land itself on that surface, right? And so every object is contextually and surface agnostic. So it can float in the air, it can attach to the floor, it can go on top of a sofa, it can go on top of a table. And we really try to think about this sort of like object resilience, that the user should be able to put any of our objects anywhere in their home, and it should feel like it belongs there. To the point where what we really tried to cultivate was an approach where users would actually move physical objects in their home to make space for our digital objects, which was something that we continue to see in user videos and in playtesting, which is kind of where that magic is, that people find our objects meaningful enough that they actually change the physical layout of their room in order to play the game. And with that, like we think about this much more like product design, and that all of our individual objects they have to be as detailed, rich, interactive, responsive as any physical object that is in the room. Because we want users to treat them like they are physical objects and like they are permanent fixtures, to the point where we started asking users, once they would take the headset off, to tell us where every object in the game was in their room. And most users could do that. They could tell you, this plant is over here, these windows are here, right? They had this memory, this object permanence. And all of that leads into this idea of making the impossible feel plausible. And so you see this, we have this storage compartment that pulls out of your floor, and when you look through your floor, the storage compartment goes down like 15 feet. But it doesn't, because it doesn't exist, but it feels like it does. It feels like there's this infinite storage hatch that goes down through your floor. And with that, right, what we're really trying to do is get to this place where there's like true cohesion between our virtual objects and the real world. And the $10 word for this is verisimilitude, which is the feeling of truth and truthfulness when in fact it is not. And so we think about this as trying to make things feel real that are not real. And we do that by focusing on intelligible affordances, that a user should be able to look at one of our objects, even if it looks a little alien and a little squishy, and understand what it's capable of doing, right? That this crank can be turned, and these handles can be pulled, and these objects operate in some way that is discoverable by the user. And that where we couldn't do that, or where we found users struggling, we would add signifiers, we would label things, which we ended up doing more than we were expecting, in part because I think users found mostly our fertilizer creatures, which you see in our trailer with these squishy little guys. They were like, what do these guys do? And so we had to do some work on that. But really with all of this, right, is that part of making this feel real is really going deep on every individual interaction. And so you see here, right, we're using hand tracking, but if the audio was playing, you would hear the slide rails of the airlock being pulled out. You would hear the gas as you click it in, right? So everything actually like feels like it is a physical mechanism. But the way that we generally actually talk about this on our team is we talk about goop. And other game designers might call this juice. but juice is for everyone else and goop is for us, which is like our kind of signature way of thinking about interaction design, which is that we think about objects that are worth interacting with. And they're worth interacting with because they make you laugh, they make you smile, or they give you some sort of superpower and let you do something that was previously impossible. And all of this with the intent to try to delight users, surprise users, make things happen that they wouldn't expect. And so a lot of this is baked into a lot of the behavior of our plants. In the game, this is one of our favorites. This is the Achis floralis, which is our little eyeball plant. And he looks at you, he follows you. He also follows objects in the scene. He's very curious. And he understands the environment that he's in a very rudimentary way. But if you poke him in the eye, he recoils and kind of looks at you like, why did you do that to me? Right? And you can touch the little top of his head and pet him, and that moves around and squishes, and you get close to him, and he's making little sounds. And if you haven't watered him, he gets a little sick, right? And every object in the game acts like this. Every object in the game has this way of speaking to you without actually speaking. And I think for us, like, this is why mixed reality is so interesting, is that we have this potential to put new memories into people's physical spaces, right? I can take your empty living room if you just moved into a new apartment, and it's now a spaceship, and it's going somewhere. You can do this in your cubicle at your office, right? That there's something really compelling, and I think Kirk talked about this a little bit, right? Of taking a kind of mundane space, or even taking your beautiful home full of plants and designer furniture, and that's an awesome spaceship, right? And that, like, if you have a cat, your cat comes on this adventure with you, and that the room is also a character. And I think that's one of the big things that we latched onto early on, is that the room, whatever room you decide to play in, is role-playing as a starship. And that you have to embrace that idea when you're building for mixed reality, because you're building a contextless game. And so with that, your game, or your experience, your app must be meaningful in any context. It must be playable in this room and be interesting. It also must be playable in a messy bedroom with garbage and laundry all over the floor, because that's where kids are going to play this game, right? And I think that idea of really embracing the room itself is part of, like, the deep magic, I think, that we found. And I'll be around later, but I'm going to hand it off to my next peer here, and I'll let Kirk introduce them. So thanks, everybody.
Thanks, Doug. I'm going to introduce this really briefly because I'd really like you to hear from the guys who've played with it. But the Passthrough Camera API. What the Passthrough Camera API does is it allows you access to those forward-facing cameras and provides that information to the developer. So you can actually take the camera frames and take them into your app. And after taking them into your app, you could feed them into an MLCV framework where you can download object detection. In fact, this very next video that we have here is showing YOLO, which is a common object detection algorithm that we just downloaded off of Hugging Face, compiled it into Unity, sent us, and put it right behind it. And you can see what it's doing is it's doing object identification. It's giving you a bounding box of where it is and a probability that this is the object that you think it is. So there's a lot of object detection stuff that you might want to use that we wouldn't provide for you. We'll identify things in a scene, but it has to be general stuff. We're not going to train something to identify a specific thing that you might want to look for. Maybe you want to look only for, white-haired poodles or something. And you could define an object algorithm to do that, put it in, and then use that in your game. This is available in a public experimental. It is accessible via the Android Camera 2 interface. And if you have any questions on that, see me afterwards, because right now I would like to hand it over to Tommy Palm of Resolution Games. Now, if you don't know Resolution Games, you should. They have a dozen really great games and one of the best and most talented teams in the industry. So with that, Tommy?
Thank you very much, Kirk. I actually been looking forward for this Passthrough Camera API for a really long time. I think it's incredibly powerful, not only for games, but I work with games, so I'm gonna show quirky examples of how we've been experimenting with it for our games. So I've been working as the CEO. I'm the founder behind Resolution Games. We've been doing this for more than a decade now. It's a very special space to get to experiment in, and you're at the forefront of technology, and it's one of the things that I really enjoy, to experiment with new stuff and create it into some new gameplay that hasn't been possible to do in the past. We started making only VR games because that was the only option, but if you look at our portfolio right now, I think most of them are actually playable in both VR and mixed reality. Demio is one of the bigger titles that we've made, where you can either play together with your friends in the same space, or you can have them join from different states and different parts of the world. And I got to work with Alicia on this together, also with Acron and Cookout. And it was a super fun project to work on. But I am here to talk about the Passthrough Camera, and here are 3 examples where we played with it in some of our internal productions. The first example is from Spatial Ops, which is a co-located shooter. We spent more than 2 years developing this, way before the technology was ready. We launched it this fall, just as the APIs for anchoring worked well enough to really have a commercial game out with it. It's doing quite well. And here we experiment with the Passthrough Camera to let users texture their objects. So it's you're playing it in your own space, the best played with friends in the same location, and you place out virtual objects and combine them with mapping out your furniture in your room, so you can duck, throw grenades that bounce off real objects or virtual objects. And it's one of these use cases where people can be skeptical to mixed reality, and then they try this and get it straight away how disruptive this type of technology is. When you in VR, cyber sickness has been a really big thing. In mixed reality, that's a much less of a problem if you have this type of natural movement. Another example that we were working on just internally for a hackathon is a concept we called Lab Rats. We've been doing these couch co-op games before, and we wanted to kind of think about how we would do multiplayer in mixed reality in a meaningful way. And in this case, we used the Passthrough Camera API to capture one player's room. So you can see that the textures are quite crude, but it works really well because it's just kind of the background for, you have virtual objects in it. So here is from the lab rat's point of view, and they have to kind of solve puzzles and mazes. And you have this asynchronous game that is really fun. And it's quite interesting to kind of visit somebody else's space. It gives for a really cool backdrop. Here's more of a living room example. So I think it's very promising to use it. This is not something that we're releasing, but it's just an experiment, internal experiment. This is something that we're actually releasing in early access. Here you can make your own textures for these very quirky, silly 20 guys that follow you around. If they're friends and families, the people you recognize, it becomes way funnier. And people internally really love this, so we decided to put it out so other people could play with it well. And you can kind of build your own gameplay experience with this. Here you're taking away gravity and trying to hit the goal there. So this is available on the store. You can check it out if you want to. And you get a chance to hit me with a baseball bat. So if you don't like what you have to say, this is your chance. That's all I had. I'll give it back to you, Kirk.
Okay, great. So that looked really fun, but we are running a little bit behind time, so I'm going to just jump right into this. Alicia, can you come?
Hello, I'm Alicia Berry. I am from Niantic Spatial. I support the Peridot IP and team. Some of them are here. Hello, thank you. I am going to speak on Hello Dot a little bit. Interesting, okay. Hello Dot was originally a port from a mobile game. That was the original idea, to take an AR mobile game, which is in market right now, and see what we could do in the Quest 3. And to our surprise, after spending about 3 months building ragdoll physics, we could almost lift and shift to the Quest 3, which is super exciting. The challenge is we lost that camera access on the Quest 3. We had been using it on the phone, and so we had all sorts of amazing features on the phone that we couldn't port over to Hello Dot. And by the way, I will plug 2 things. One, Hello Dot is available in Quest 3 right now, and we're about to launch a big update, so stay tuned. And 2, if you'd like to know more about Hello Dot, Ashley Rosenbaum from our team has a topic tomorrow called Less Coding, More Booty Shakes, and I really encourage you to attend. It's going to be very interesting. So let's show you 2 videos. So you might say, hey, this looks like VR, and you're right. Because at the time of building this deck, we had not fully integrated Hello Dot with the camera access, but I want to show you what we're thinking about. And so the first video on the left is basically a dot booty cam. So it follows the dot through the room, and if you have ever worked with mixed reality, you are limited by the cameras that are here. So like Tommy's example, where you could like have a room and move about that room, really when in mixed reality, you can only move around the cameras. And so in this case, we are able to, if we have a scan, a Gaussian splat of the room using our app called Scaniverse, we can render that in the Quest 3 and then layer on animations. And on the left here, we have like the slow motion dot cam. So we're super excited about what this could bring in terms of UGC. Imagine if you had no skills in terms of video editing, but you could create a 3D scene in VR and then make 2D rectilinear videos. We think this could be very compelling. Our second is this very late-breaking video here on the left. Uses a lot of what Tommy was talking about, and also Kirk, but that's our own ARDK light chip. It is using our object detection, and you see Luis's dog here, where it's like, it's an animal, it's a turtle, it's a cat, and Gen AI is driving that animation, which we also have in our mobile app here. And this is in market right now, so the dot sees a tree and gets pretty excited about it, and this player got in-game currency by completing a quest. And so what we imagine with camera access is really pushing the boundaries of virtual objects. And so you could pick up like a blue marker, a real blue marker, and take a blue marker and color your Peridot blue. Or imagine you had a virtual eyedropper and you could pick any texture and drop it onto something else. We really imagine this to be kind of a Rubicon for people to be able to get into UGC without a lot of technical knowledge. And then finally, our last use case is pretty canonical. I'm sure you would have loved to have this during GDC, which is the ability for wayfinding. And this is, again, a mobile app, but we have the ability to render this on the Quest, and we expect to have this very shortly, maybe H1, where you've got Peridot navigating through a Gaussian splat and wayfinding. And what we know, there's a lot of AR apps on the market that could be doing this on the Quest, and all of a sudden, there's this new place that AR apps can now be in an immersive headset. And we're super excited about the possibilities. And we'd love to come back next year and have you in your Quest and being able to find your bathroom or the snack area with Peridot. So imagine your tidy use case if you could use this for, I don't know, doing quests in a real world, like an MMO. That's what we imagine. So for us, this is just the beginning of really gamifying the real world. And guess what? The real world is full of high-fidelity assets, and they're all free IP. So I'm super excited to dev with you. And if you'd like to reach out, please reach out, and we could talk more about some of the Niantic technology that's already enabled in using the Quest Camera API pass-through. And with that, please play Peridot, and I'll hand it back to Kirk.
So unfortunately, we are right at time right now. At least that's what my watch is saying. Here's a couple of QR codes to go and get more information. I'll give you guys a second to take a picture of that. Just to kind of reiterate where we are with the Camera Passthrough API, it is available in the public experimental release. All the documentation is online, so you can download it today if you want to and start playing with it. We can't wait to see what you do. I mean, again, the ability to take your own object detection algorithms or MLCV algorithms and apply them directly to the input is just amazing. And the AR case as well, AR with a camera is not hands-free. AR with a Quest is. So the things you can do with that, from gameplay to industrial apps, it's just absolutely amazing. I'm going to put one more slide up here. Please, if you get a chance, take a picture of this, go to this, and give us some feedback on how we did in the session. With that, thank you very much. Oh, one other thing. There's a breakout room, I think, in 2014, if I heard the room right. So me and the other speakers will be over there if you have other questions you would like to ask us or more detail. Thank you so much for your time and attention.